Hello. In this video, we're going to go over some examples of how we can use JavaScript functional programming and higher order functions to help us write loops in a simpler way. So this is going to be more examples of how we might use callback functions, of the kinds of methods built into JavaScript that require callback functions, so you can get practice with using those and see how they might work, as well as learn about some useful methods that are going to show up quite a bit in future JavaScript programming that we're going to need to do. Okay. So one of the things that we can use functional programming for, that we can use JavaScript functions and sort of passing functions or callback functions to do, is to do them for doing array iteration. So this is so arrays come with a method built in, right? JavaScript provides a method on arrays called for each. And the for each method will allow you to specify a function, and then that function will get called for each element in the array. So this is another way of writing a for each kind of loop. This method existed before the for of syntax existed. So this is actually a slightly older approach. For of tends to be a lot cleaner for what we're trying to achieve, but I want to use this as an example of the kinds of syntax that we might use. So I've got sort of the shortcut example here. I'll walk through the longer version of this. So imagine that I have an array, and I have my people array. If I want to loop through this people array, right, I could say let's say I want to do something for each person in this array. I could define that thing I want to do as a function. So for example, I can make a function called print name that takes in a person. And then what this will do is it will get their name by going to person.name, and then it'll console.log their name. Right? That's what this does. So I'm defining a function that's going to work on a single element in my array, and then it will do some work, and then I can pass in that single element, and I can see if the function did what I expected. So this scene is very simple. It's a very simple kind of basic example, but we're at least trying to go through the syntax of what we're going to do. So you can then imagine, of course, I could write a standard for loop, right? I could say for const current a person of my people array, and then I could say I want to print the name for a person. Stop. Space here. And that will then go through, right? I'm going to say go through every element in my array and print out that person's name. Great. That seems reasonable, right? I mean, maybe it seems a little silly that I made a function to do that, but pretend for a moment this function could be much more complex. Maybe I'm trying to calculate like their body mass index or something based on their weight and height, or there's something complex operations happen. I want to encapsulate that in a function for testing and understandability and reading and stuff. So with that in place, right, I can run my code and it'll print out each person's name. Ada, Bob, Chris, Dia, Emma. Yay, life is good. This is a basic for loop. What the for each method will do is, rather than writing out a for loop, right, I don't have to write that for loop itself. What I can do instead is I can say, take my people array and say for each element in that people array, and then specify what function do I want to call when I pass in a person, right? What function I want to call who's going to take in each one of those people as an argument. I'm not calling the method on them. I'm not saying a person dot print name. It's print name with a person coming in as an argument. And I can say people array for each one of these things, print their name. And this ends up doing exactly the same work. It produces the exact same kind of output. The for each method has a for loop built in. I don't need to write any for loops myself. I can just say, take my array, and then for each element in the array, do this function. Note that I'm not passing in parentheses after the function, right? I'm not passing in the result of calling print name. I'm saying, here's your instructions for what to do for each element in the array. Now, whatever function I pass in, this print function, right, this iterator function, whatever gets passed in, it's going to get called on every element, passing in that element as the object, as the argument to this function. So if this function, for example, expected 2 arguments, person and then a last name, or how about person and then age? I don't know. Right? If we try to log out the person and their age, what ends up happening, oh, that didn't work. The second argument actually ends up not being their age. It ends up actually being an index. It ends up being something else. Effectively, it's not defined clearly. I mean, it is defined clearly, but it's sort of not defined the way we expected. So this function, when it gets used, is getting used only in the sort of in the way it is expected. Right? I have to structure the function correctly, right? It has to take in that person, right? If I tried having it take in the age first, then the whole thing will crash because person age.name isn't defined. So that'll let us be able to get to what we need to do. So again, this is just another way of writing a for loop. Arguably, I don't know, it could be better, right? In that it's definitely less line of code than writing it out like this. So if you have a function, like a print name function, and you want to say use that function for every element, this can be a faster way of doing that. It's certainly cleaner than using the for I is equal to 0, I is less than array.length I plus plus structure. But again, this came out before for of existed. And then, of course, we can use, I mean, I've written my function declaration this way, right? Because it's a function declaration, we can also, of course, write it out as by taking a function literal and assigning it to that name. That's the thing we can do. If we then take that function literal, I can literally copy this and replace it. So instead of saying print, use the thing labeled print name, I could say, let's actually just put in the literal value itself. And when I do that, I now have my function again, right? I'm going to say for each person, go through that person, get their name, and console log that out. Which, again, does the exact same thing that I wanted. This has the... So again, the way we read this, you just say, my people array, for each element, do the function on that person, where the function is doing this kind of work. You'll note that if I was trying to write out my loop without the function, I'm basically getting the exact same thing. I've just replaced for constant person of people array with people array.for each function person. I've just kind of like reordered things around a little bit. I guess the better to be person. I've just reordered how those things work together. So this is a very standard, common way of writing these, passing in these kinds of arguments. I'll note now, because I realized I forgot to do it in the last recording, when we pass in that function, I get this kind of weirdness at the end, right? Where I have close curly brace, close parenthesis, semicolon. The close curly brace is closing the body of this function. The close parenthesis is closing the argument list of for each, not the argument list of this function inside of here. It's the argument list of the for each. In Visual Studio, if you minimize, you can use on the gutter here, you can minimize some of these lines of code, and that clarifies a little bit what's going on, right? I'm calling people array for each and passing in a function. Ignore what's happening inside that function, right? The syntax for each says people array.for each, pass in a function. That function then does some work that I want to do for each element. So that's an example of our functional looping, right? That's a way that I can use write a for loop just using functions. I don't actually have to write the for loop myself. Right. Again, for each is kind of, it's not super useful these days, right? For of exists, and for of is cleaner and generally gets you where you need to go in a slightly better way. It's a more effective structure. It's a little bit faster. It's just overall better. But for each, this method is a really good example of how we can do this kind of functional programming, and it'll lead us into the next example that we want to do. Okay. Right. It's more common that we might use an anonymous literal function when we're trying to put this together. The next variant, the next piece that's similar to for each, is the most important function in all of JavaScript. This is my favorite function in JavaScript. I think this is the most important thing you will learn when you're learning JavaScript for this class. This function, the method we're about to talk about, is going to be used all over the place. It's super, super important that you know and that you realize and you remember and you understand how it works, because we use it everywhere. It is super, super important. Now that we've acknowledged that this is really important, so everyone is, of course, paying super close attention, let's talk about mapping. So the mapping method takes the elements in an array, it goes through each element, and it maps that element into a new element, into a new array. So what you can really think about doing is it's going to go through every element in an array. It's going to transform each of those elements into something new and put those new elements into a new array. So the way this looks, if I was just writing this out as a for loop, right, what a mapping operation would look like is I might have a function that takes in an input, a number, for example, and then transforms it. In this case, we square it. We multiply it by itself. You can think of this transforming any way you want, right? Maybe these are a bunch of like, Clark Kents that all put on their superhero outfits. Like we're taking some set of values and transforming them into a different set of values. So I can then take my initial array of numbers. I can define what is the new array I'm trying to produce, right? Because I'm trying to say I've got my old array of numbers. I don't want to mess that up. I want to make a new array that has all my squares. So I'm going to make my new array for squares. I'll define that initially as being empty. I'll then do a standard loop. I'm going to loop through all my numbers. I'm going to transform each number at a time. I'm going to say go to number index I, go to the first number or the current number I'm on, transform it by calling my transformation function, assign that to a local transform variable, and then I'm going to push that transform variable into my new array. Cool. So it goes to the first element, transforms it, puts that in the new array. Goes to the second element, transforms it, puts the new array. Third element transforms it, puts it in the new array, and so on and so forth. So that in the end, I can log out my squares, which is now my new set of transformed element, my square versions of things. My original numbers array still exists. Here's my squared version. Cool. The map function lets us do that entire loop, all of that work, in a single line of code. That's pretty cool, right? I've converted this, which is, that's kind of terrifying, a little bit pain in the ass to read. Look how many brackets and things there are. And it converts into a single line of code. What we're able to do is we're going to say, go through every numbers, map them, transform each one through this transformation function, and put that new transformation function, that result, into some new array. Awesome. So we can do this kind of thing as in our example. We've got our people array. I can do some work. For example, let's make a transformation function. Let's call a function. Let's do a get name function. Sure. For a person, and this function is going to, so instead of printing the name, I'm going to just get the name. I'm going to use most of the same work. It'll be kind of boring. That's fine. I'll return the name. So I have a function that says, if you give me a person, I will transform that person into just their name. Sure. How about, we'll do an add hat function. How about this? So it takes in a person, we're going to get their name, and we're going to return their name plus in a hat. A little better. Now we're actually transforming them, right? We're putting everybody into a hat. So we take an object, we get their name, we can put them in a hat, return that string. How the mapping function can then work is I can say, take my people array, and I want to transform each of my people array by adding a hat to them. I'm going to give each of them a hat. Great. Now, that new set of people in hats, those names in hats, need to go into a new array, right? I'm not actually modifying people array, I'm making a new array. So I need to declare that new array. This will be my hat array. And my hat array will now be the result of mapping my people through this add hat method. I console.log my hat array. Now I have an array of strings, each string of which is the name of that person in a hat. I've transformed every person into a hat-wearing person or hat-wearing name by using this mapping function, by using this mapping operation. Note that I didn't write a for loop. I never used the words for of, or for each. I never wrote a for loop. The map function contains a for loop inside of it. All I had to do was specify what I want to do for a single person, and then say, do that thing over and over and over and over and over again. Do it for every element in the array. And that gives me my mapping kind of operation. Importantly, very coolly, right? This mapping function took an array of objects, right? Because that's what my array of people were. And it converted it into an array of strings. So the mapping operation converts from an array of one type of element into an array of another type of element. mean, it doesn't have to, right? My square example converts from an array of numbers into an array of numbers, but this mapping operation lets me convert from an array of objects into an array of strings. This is incredibly useful for client-side development because we can take data structures, arrays of objects, like my people array, and we can map them into the kinds of content we want to show on the screen. We can map them into an array of strings. We can map them into an array of HTML elements. We can map them into arrays, lists of content to put on the screen. This becomes a very effective tool for letting us be able to convert data into content display dynamically in the web. So we will get back to the web eventually. We're still learning some JavaScript, but we'll get to the web back there eventually. But this is the kind of thing that becomes really useful for us to use. Right? I can convert it. So you can imagine that if my add a hat also put them inside of a list item, I can now make myself an array of list items, which would be really interesting. Okay. Actually, I'm going to show you what that looks like. So if this add a hat function, let's make a different one. Let's make a put in list function, person, and I'm going to make a list string, which is going to look like a list item plus the person's name plus close list item. This is not actually how this will be used in the web, but I want to give you a sense for like why this is important. I can turn that list, that li string. I can then go ahead and again take my people array. Oh, that's space. I'm going to map it through my put in list function, right? So I'm going to say take each element and put it into a list. That's going to make my new LA or li array. If I console.log my li array, now you'll notice I have a list of list items that have all the people's names, which seems like a pretty good first step towards getting me to be able to say, take a bunch of data and put that data on the screen, make a whole bunch of cards, make a whole bunch of list items, make a whole bunch of stuff representing all of that data. And that's the kind of logic we'll be using map to do. We won't do it quite in this way. We're not creating strings. We're creating other data structures, but that's kind of the way we're going to start doing it. And note, because I was making a brand new array, my people array hasn't modified. So that's why I'm allowed to make both hat versions of them as well as list item versions of them as well. All right. It is, of course, slightly more common to do this mapping by using a function literal, right? Again, we're not going to define a separate put in list function. What I would do is I would take this function, let's convert it into our literal version. Put in list is equal to this function. And I can then take this function and put that directly into my mapping. Right, so I'm going to say take my array and map it through this function for every person, where in that function, I'm going to create the thing that I want to return, the new transform version, and return that transform version to put into my new array. And again, this gives me the exact same results. Oh, wrong button. Gives me the exact same results of my array of list items. Mapping is super, 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 super important. We use it all the time. There's so many situations we'll get to where it's like, how do we solve this problem? We're going to map it. How do we structure this code? We're going to write a mapping function. We're going to do so much mapping from data structures into displayed content. That's how we move from the data into the display. We map from data into display. So you're going to get really used to using map. We're going to be using it all the time. The syntax, the pattern for map, right? Mapping op functions always look the same. They're always built out the same way. So the template that you would use for mapping, and I'm going to write this out now so you can see it, right, is you're going to define your new array. That's an important step. Often people will forget to do that. They'll call my people array.map, right? They'll get the mapping part done, and then they'll get the fact that, well, I have to label that new array it's producing in order to actually make this all come together. Stop. So you have to define your new array. You're going to take your old array, and you're going to call map on it. Map is going to take in a function. That function is going to take in each element, each item in the array. And that's the function callback we're going to pass in. It has to expect that item because we have to know what item are we transforming. Inside the body of that mapping, this callback function then, right? This is inside the callback. I'm not inside of map. This is an argument I'm passing to map. In this callback then, I'm going to make a new transformed version, which is going to be doing something with my item. Something. Right, I'm going to do something to it. And then I'm going to return that transformed version. It's very common for people to forget to return something. If I don't return a value, right? If I forget to return this li string, stop for a second. If I forget to return that li string, if I just create it, then in my new array, I end up getting a whole bunch of undefineds because it says what value did, after you map something, what value did it map into? What should you put, what gets returned out a result to put to my new array? If you don't return anything, you get a whole bunch of undefines, and then that's not very useful. So don't forget to return that value from the array. Okay, this is our template. You're going to write this all the time, right? If we want to write some mapping, we're going to say define what I want my new array to be. My old array.map from functioning through whatever items it has, transform those items in some way. That's the sort of the meat of the operation, and then return that transformed, and that will give me my new array. It's my mapped array of all my content in place. Awesome. Again, map is super important. It's super useful. We use it all the time. Coming out of the template, so we can keep writing code. Okay. If we're talking about mapping, we also have to talk about mapping's sibling, like mapping's best friend. Sorry. Mapping is super important for practice. If you're watching this video at home, pause the video, take some time to practice writing out your own array and mapping that array. Try to be able to make sure that you are able to actually be able to get mapping working. You can write this code and it works. Get used to muscle memory. Get used to typing it out. It's very important. You'll need to do a lot of it. Mapping's sibling, their brother, right? The thing that goes along with mapping is filtering, right? Map and filter. They're like this. They're tied together. So filter is another method that exists on arrays. It's another looping method that works really similar to map, except that what it does is instead of taking every element and transforming that element and putting a new some other weird with hat version into an array, it instead goes through an array and only puts into the new array elements that pass some requirement, that meet some condition. It filters for those elements. This is a filter in the same way that we talk about filters in R. We don't think about filtering things out, right? We're not trying to get rid of stuff. We're really thinking about filter for what do I want to keep? What am I going to allow through the mesh, through the filter, right? Basically, what gets past the bouncer at the door. Okay. So the way that filter works, filter is going to, again, be a method we call on an array. It takes in a filtering function, so another callback that's going to, again, take each item, each end, just like we're working on. And what it does is it's going to return a Boolean, true or false. It's going to return whether or not that element passes the filter. So, for example, I can say, I can make a new variable that could be tall people by taking my people array and filtering my people array. So I'm going to go through each function for each person. I apologize if that's wrapping around, but that's sort of how much screen space we have. I can say, should keep is going to be whether or not that person height is greater than 70. We'll say that's tall. If they're higher than, actually 72, right? If they're more than 6 feet, is that 6 feet? 5 feet? If they're more than 5 feet tall, we'll call them tall. That's 5 feet. I don't know. I can't do math. And then we return that Boolean. Note that I'm not returning the person. I'm returning a Boolean. I'm returning yes or no, true or false. True, let them through. False, don't let them through. And then if I console.log my tall people here, whoop. Person not people.height. That gives me my array of everybody who's tall, which is just Bob. Bob's the only one who's over than 72 feet tall. If we do greater than or equal to 72, I think we can get one more. Nope. How tall are my people here? Fine, let's go over 70. Emma is over 70, so let's call Emma tall as well. So if we do greater than or equal to 70, then I can get 2 people, Bob and Emma. Because again, I'm saying make me a new array that's going to keep track, that's going to have only copies of the people who pass this criteria. Filtering is great. It's useful, right? Again, because we do a lot of data filtering. It's a good core data processing kind of method that we might want to use. And it works the same way as map and as for each. We don't actually write a for loop. There's no for loop here. We just say, here is the function that says, should I keep you or should I not? And then we pass that function into the filter method in order to determine whether she keeps them or not. There's some languaging here that gets a little bit confusing. This thing here is the filter method, often sometimes called the filter function. This thing here is a filtering function, because it's a function that's going to do the filtering work. It's the filter, determines what something that gets through. So that thing there is often referred to as the filter, the filtering function, or sometimes just the filter function, because that's the function that does the filtering. So then you get this kind of confusing piece of language when you have to distinguish between the filter function and the filter method, which is itself a function. And if you're not careful in how you're speaking or writing, and you'll see this in some of the problems that's potentially, as I'm trying to be careful about speaking and writing, but it can make mistakes. It can get confusing about what piece you're talking about. So again, be careful to distinguish between the filter method, filter, and then the function we're passing in, the function that's indicating how to do the filtering, the method function. Oh God, no, the filtering kind of behavior. Okay, we've talked about map, we've talked about filter. If we talk about map and filter, you have to sort of talk about sort of their distant cousin, who's called reduce. Map, filter, reduce are sort of they're a trio. Map and filter are really close. They're really next to each other. Reduce is kind of the tag along child, but you should also keep in mind how reduce works. I guess I want to give you an example of reduce because again, this is further showing how these kinds of callback functions end up behaving. So reduce is another looping kind of behavior, right? It's another function that's going to do some looping work. It's going to loop through an array. It's a method we call on an array. And what the reduce function does is it uses the callback function to indicate how it wants to combine all the elements of the array, right? How it wants to build them all together into a single value. How it wants to reduce them down to a single value. This is really similar in behavior to like the summarize function from R, right? The summarize function would say, like, take a vector of values and summarize them down to just their into like just their average or just the biggest or just the ones that are, you know, how many are red, right? Count them in some way. That kind of like, let me summarize this data into a single value. That's what the reduce function is used. The reduce function takes our function is called a reducer. That's kind of this process we're going to use together. So as a contrived example in our slides, right, I have a function here called link that takes in two values. It takes in sort of the accumulated value so far, right? What's the sort of combined string that I'm getting so far? The accumulation, right? How are these things building on top of each other? And then it takes in a new item. It takes two arguments, right? What we've got so far, and what's the new thing that gets added to our list. So we then are going to produce a further accumulation from that. We'll make a new accumulation by taking the old everything we've got so far, adding a little arrow and adding that new item together, and then returning that new accumulation. So we're going to say, like, I'm going to take a little string and a new element, take the new element, add to the old string, and return that bit. Then I can take that new bit, add a little bit to it, a new little string to it, that makes it longer, add together, right? This keeps sort of linking and knotting these pieces together. It keeps adding more and more pieces. It's almost like if you're building with Play-Doh, or, you know, silly Play-Doh or something like that. Like, you've got your little ball Play-Doh and keep adding new strips to it and keep growing it and growing it and growing it and growing and growing it. That's the reducing function is doing, right? I'm taking a whole bunch of strips and I'm combining them all together at once. If you ever play like Katamari, it's the same kind of thing. Like, you're rolling your trash ball around, you keep adding new pieces to it and reducing them all into a single ball of trash. Cool. So that's our behavior, right? We're going to say, in order to build out this sort of this linked set of strings, I'm going to take my array of strings. I'm going to start off with something empty, something basic. I need to say, where am I starting my sort of linking, knitting behavior from? I'm going to go through all my letters, take each letter and link it, add a little arrow in that letter to my sort of growing string. I'm going to keep sort of sewing and combining them all together, so that in the end, I get them all linked and it produces this nice string of A, B, C, D, E with little arrows between them, right? It's like I'm doing embroidery kind of effect. The reduce function does that exact same work. It does that reducing without actually needing us to write a for loop. We can say, how do I want to combine things together? Where do I want to start? And then that will then get me then I can then use that to reduce through my total letters. Okay. So let's do another example so you can see how this works. So let's do an example where what I want to calculate is the total weight of all my people. I want to know how heavy they are. I want to know if they can all ride on the same roller coaster together. I'm going to figure out how much they all weigh. So what I'm going to then do is I'm going to take my people array, and I'm going to try to reduce all that array of objects into a single number, total weight. So I'm going to call reduce on them. Reduce is going to take in 2 arguments, slightly different. The first argument it's going to take is the function, right? We need a function that's going to know how do I combine these things together. The second argument it's going to take is what value am I starting at, right? If I'm going to combine these things all together, what am I combining them all to, right? What's the starting root part of that? I'm calculating a total weight, so my starting value could be 0, right? I'm going to say, like, initially, before I've added anybody to my scale, my initial total weight is 0. So that's my starting point. Okay. So here's my function. My function is going to take in 2 values. One is going to be the accumulation, and one is going to be the new person. The accumulation is like the total weight we've got so far. We could even name it total so far. Accumulation is kind of the standard labeling for this thing that you'll see in a lot of reduced kind of behavior. So I want to sort of use that so you get used to that word. You'll see accumulation, cumulatives kind of thing. Like that's what's going on here. Cool. So what I'm going to do then is make my new accumulation, which is going to be my old accumulation plus the new person's weight. And then I'm going to return that new accumulation. What the reduce function will then do is it's going to go through the array. It's going to take each person and it's going to combine them, right? It's going to do this addition part. It's going to combine them with my existing total weight. And it's going to keep adding on to that same accumulation over and over and over again, having it kind of keep growing and growing and growing and growing until we have the overall total. And then if, of course, I console log my total weight, the total weight of all my people is 726, which, as we do a quick sanity check, it's always going to do a quick sanity check, right? 135, 150, there's like 5 values here, each of which is just under 150. So that sounds like that should get us to about 750. So yes, that looks like it did the right thing. So in this case, my reducer function was a sort of a quick way, and not quick, but it's sort of another way of me doing like a totaling behavior, right? Instead of having to keep track of a running total, the reducer function kept track of that running total for me, so that all I had to think about was I want to reduce these values by some function. I didn't have to actually do the keeping the running total for me. The reduce function did that on its own. Cool. The reduce function is cool. There's some particular kinds of structures and frameworks and mappings that you in concept JavaScript that use reduce a lot. Redux is the really big one. It's not super popular. It's popular these days, but reduce can be there's a lot of data processing behaviors that are big on reducing. That said, it won't be quite as important in a lot of the work that we're doing. Not like map. Map is so important. Map is the most important thing you're going to encounter. Reduce is just kind of a cool, fun side effect, though, but it goes along with, and I want to make sure that you're at least aware of its existence, even if you never actually end up using it. So that's our basic trio, right? We've got map, filter, and reduce. Map is super important. Filter is useful and it's used a lot. Reduce is kind of cool, but maybe not as useful as we go. So again, I've got some practice if you want to practice using reduce along the way. You can pause the video to do that and come back. Otherwise, to summarize map, filter, and reduce, explain with emoji. So if I had a bunch of emoji, if I had a cow, potato, a chicken, some corn, I could map them through a cooking function, and that will output a new array of a hamburger, which is a cooked cow, some fries that are cooked potato, some cooked chicken, and some popcorn, which is cooked corn. Ta-da! We've mapped my array of raw ingredients into some delicious food. I can then, of course, take my array of food and filter it for what values are vegetarian. If it is vegetarian, it will get kept. If it's not, it does not make it into the new array. So my new array keeps only the vegetarian options, which are my potatoes and my popcorn. And of course, I can take my reducer function. I can take all my delicious food and reduce it through an eating function, which combines it all together into a single value and outputs that single value at the end. And we will end on a poop joke, and that's the end of our structure. Cool. That's the basics of, again, functional looping. We will use other callback functions, and we'll be passing functions into other methods, particularly to do things like add interactivity. But that's kind of the basic ideas for how we can begin writing these sort of functional kinds of components and be able to passing functions into other.